Hello everyone, welcome back to another kinetic tutoring episode. Today we're looking over a quick review of Chapter 2 in AP Statistics, so let's get straight into it. The first question we have is baseball salaries. Brad Lidge played a crucial role as the Phillies closer, pitching the end of many games throughout the season. Lidge's salary for the 2008 season was $6,350,000. Part A asks us to find the percentile comparing to Lidge's salary. Explain what this value means. So, in order to do this, we have to find Lidge's dot on this graph. And so, his salary is between 6 and 8 million. The only dot that corresponds to that is this one right here. And then we have to find out how many dots make less money than him. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 dots make less money than him. And that's what a percentile is. It's saying this many percent of people make less money than me. So therefore I'm in that percentile. So how do we convert this into a percentile? We divide it by the amount of dots which we can count, but it's also given to us here, 29. So divide 22 by 29 to get our percentile. 22 divided by 29, and then we would have to multiply this answer by 100%, or by 100 to get 75.9% when rounded to one decimal place. What this signifies is that Brad Lidge makes more money than 75.9% of the other people, the other Major League Baseball players in this sample. Part B is asking us to find the z-score. The z-score is how many standard deviations he is away. First, we need to find how many dollars he is away from the mean. So, in order to do this, we take his value, his salary, and subtract the mean salary. Let's do that. 6350000 minus 3388617. And we get that he is $2,961,383 away from the mean. Now we need to find out how many standard deviations he is away from the mean. And how we would do this is by simply dividing by standard deviations. One standard deviation is $3,767,484. Let's put that in here. All right. Sorry, I had a misinput. All right. So what we get is 0.786. We're just going to leave it at that. 3 decimal places is going to be 0.786. That's how many standard deviations Lidge is away. Noticing that this number is positive, what this signifies is that Lidge's salary is above the average salary. Hold on a moment. I'm going to close my door because my little cousin is at my house. And I don't want any noises or anything to disrupt the video. So this would be the z-score. And z-score and how many standard deviations a value is from the mean, they're the same thing. And yeah, as you can see, it's less than 1 z-score away. So, but it's away from the mean, obviously. So let's move on to the second problem. Gonna erase all this and carry on. Here are the lengths of 44 great white sharks. Here are the lengths of 44 great white sharks. Now it says enter the data into your calculator and order it from smallest to largest. We do this by going on our calculator, clicking list, edit, and in list 1, you're going to want to put just 1 through 44. All you're going to want to do is put for the first section 1, first column 1, second column 2, third column 3, and so on and so forth till you reach 44. For the second section, for the second column rather, for the second list, L2, you're just going to fill it in with these values. First column, 12.1, second column, 13.5, go all the way down till you reach this last value, 18.7. Once you've gone there, you're going to press second and then quit into the main menu, and then you're going to press stat again, and then you're going to press 2 or go to sort A, enter, and once you have sort A there, you're going to press second, L2, enter. It's going to say done. Now you're going to press stat edit again, and your list should be in ascending or descending order. Ascending or descending. Hold on. It's going to be in ascending order, meaning that the numbers get larger and larger. So, part A asks us to construct a histogram. So, once we have collected these values, we're going to construct a histogram with our data, which essentially is a bar graph. So, as you can, okay, so the histogram we're going to create, we're going to have a y-axis and an x-axis. And now we're going to have our x-axis is going to be lengths in feet, where it goes from the smallest value, which is 9.4. We're going to do 9. And then we're going to have 10. Since our lowest value is 9.4, we want to include all whole numbers that encapsulate all the values. So since it's between 9 and 10, we're going to have 9 be our lowest value. And let's see what our highest value is by scrolling all the way down to the end of list 2. It's going to be 22.8. So we're going to keep this going until 23, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Now with the histogram, I've clearly ran out of space. Or actually, no, I can just write it down here. You're going to want to say length of sharks in feet. Length. I'm going to leave it at length, but preferably you want to put length of sharks. Make sure to write your units. And then we're going to do number of sharks for our y value. So let's see how many are between 9 and 10. So we're going to have this be our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's only one between 9 and 10. That's our 9.4. So the height of this box is 1. There's not going to be any between 10 and 11 or between 11 and 12. But there's a few between 12 and 13. We have 12.1, 12.2, 12.3, 12.4, and 12.6. How many values is that? 1, 2, 3, 4, 5. So the height of this box is going to be 1, 2, 3, 4, 5. There you go. Now let's go to 13. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 values for 13. 1, 2, 3, 4, 5, 6, 7, 8. Should be approximately this tall. Bring that over. This is much easier on a piece of paper with a straight edge, which I definitely recommend that you use if you're taking an exam or anything of the sort. Let's move on to 14. 1, 2, 3, 4. We have 4 for 14. Should be approximately this tall, just a little bit lower than the 5. 15, we have 1, 2, 3, 4, 5, 6. 6, a little bit higher than the 12, but not quite as tall as the 13, which had 8 sharks. Now let's go to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. That's our highest value yet. It's going to be almost at the top. Let me make sure that's accurate. Pretty much. It's close enough. I'm not going for accuracy more. I'm more going for concepts. But I'm going to label how many sharks there are per each box inside the box, just for viewer clarity. So we have 5 in this box. We had 1, 2, 3, 4, 5, 6, 7, 8 in this box. For 14, we had 4. For 15, we had 1, 2, 3, 4, 5, 6, 6. Here we had 9. Let's go to our 17. 1, 2, 3. There's 3 for 17. So it should be a little bit smaller than the 4 box, or the box with 4 sharks in it. There you have it. 18. 5 values again. Should be as tall as this box. There we have it. Now we move on to 19. 1, 2. 2 values for 19. And 0 for 20. 0 for 21. And then we have 1 between 22 and 23. Alright, and that's going to be 22.8. Now, describe the distribution. I'd say this is pretty evenly split. We don't have too much of unevenness going on. Like if we were to say somewhere around here is the center, there isn't significantly more data on the left or on the right. I'd say it's pretty normaled out, pretty like averaged out. Here we have 13, 17, 23, not including these 2 outliers, and that would mean that we have 19 over here. So maybe very slightly skewed right, but it looks pretty much normal. Compare the mean with the median. So the way we would find the mean here is we'd go to stat, calc, 1 variable stats. We'd put list 2, and our frequency of list 2 is going to be list 1. We calculate, and it says that our standard deviation is approximately 2. Our average is 16 point, or sorry, we're not looking at the standard deviation. Our mean is going to be 17. Not 17, 16.96, which is approximately 17. Mean 16.96. Now, in order to find our median, this is an even amount of data, so it's going to be, the median is going to be the average of the 2 center points, which are, in this case, 22 and 23. So we go to our list. List 2, we look at 22 and 23, which are 15.7 and 15.8. And the average of that is 15.75. So that is going to be our median. And they look somewhat similar. Median is a little bit smaller than the mean. That's what I would say. Does this confirm what you said about the shape of the distribution? All right, guys. So if it is normal, these two should hypothetically be similar, but as we could see, the mean is greater than the median. So there's something that this signifies. I have it in my notes right here. Let me pull it up. When the mean is greater than the median, that means that the graph is skewed right, meaning that there's less values on the right, which is what we predicted here, which means that, as you can see, since we had less values on the right, only 19, not including outliers compared to the 23 on this side, that is why, sorry, excuse me, the mean is going to be greater than the median. But as you can see, it wasn't too significantly, there were only 4 more data points here than here, and therefore they're pretty similar, just a little bit of difference. C says calculate the percent of data within 1 standard deviation of the mean. So for this, we're going to find our standard deviation, which we do by saying stat calc, one variable stats, calculate, and our standard deviation is approximately 2.19. So our range is going to be 16.97 minus 2.19 to 16.97 plus 2.19. So 16.97 minus 2.19 is going to get you 14.78, and then 16.97 plus 2.19 is going to get you 17.06, 17.16, 19.16. So we want to see how many of these data points are within this range. So we go to our list, and we just take a quick peek. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 values out of the 44. I'm going to delete all of this. 25 out of the 44 values are within that range. So I'm going to rewrite the standard deviation 2.19, and the mean is still on my calculator, so we'll go back to that. 25 divided by 44, let's calculate that. It's going to be around 56%. Now, 2 standard deviations and 3 standard deviations. Let's do the same thing. All right, so let's see. We go to stat, calc, one variable stats, and we calculate. Sorry about that. All right, so we have the length. Okay, so we have our 16.96 as our average. And now we're going to find 2 standard deviations, which is 16.96 minus 2 of these, to 16.96 plus 2 of these. So 16.96 minus 2 times 2.19, which is 4.38, gets us 12.58. To 16.96 plus 4.38 gets us 21.34. And using the same method we used to get the amount of the numbers in the first and within 1 standard deviation, we can do the same thing for the second and the third. And the pattern you'll notice is for all 3 of them, the values are going to be smaller than the rule which we were expecting, which is the 68, 97, 99.5. And the reason for this is that there are not that many data points. if we would have like 200 great white sharks that we were measuring, you would expect it to be more like 60, closer to one standard deviation being 68%. If we had a million great white sharks, it would be pretty darn close to 68%. But since we're only taking into account such a small sample, that is the reason for our 56%, which is 12% away from what we were expecting. So I would say, due to the big error, the distribution is not approximately normal. It's a little bit skewed. That is also another thing we have. It was skewed right. We had more values to the left than we did to the right. A normal bell curve is not skewed, so it would be attributed to the skewing of the graph and additionally the small amount of data points, which is why we cannot consider it approximately normal. That's all I have for you guys today. If you have any comments, questions, or concerns, make sure to leave them down in the comment section below, and I'll try to address those as best as I can. If this video has helped you, make sure to leave a like and subscribe. That would help me greatly. See you guys next time.